This is going to be just a short little video showing you a special picture. This, it's a notion that occurs occasionally. It doesn't occur a lot, but when it does occur, it is the only tool to get you the job done. And so I want to familiarize you with this picture here, particularly if you end up going on to take Calculus 1, you'll see this picture, and if you understand it and you see what's going on, then you understand what your instructor shows you. And I've had students that understood this picture. It was shown to them in trigonometry by whomever they had, and so it made perfect sense to them. I had other students that didn't make sense to them. They had to come into my office afterward and say, why is this picture working? I had to go through this little demonstration for them. So this will help you get a leg up if any of you go on to take Calc 1. So what I have here is an angle theta in standard position. I have C is the center. I have point P is the point that angle crosses on the unit circle. And R I just labeled as the point 1, 0. Yeah? So we know that since this is the unit circle, if I drop this perpendicular, I know what the length of that line segment is if you know the value of theta. So let's assume theta is given. And for now, let's assume theta is in quadrant number 1. If it's in other places, a similar picture can be made, depends upon where it falls. But let's assume for now, theta is given in quadrant 1. It doesn't need to be, but the picture becomes there's a little more going on if the picture's not in quadrant 1. And so for our purposes, it will suffice to say theta is a quadrant 1 angle. If that is the case, and we drop this perpendicular, I'm going to call this point Q. Then I know this distance, and I know this distance. I know 1 is from C to R, but from C to Q, I know that distance, because the x-coordinate is the cosine of the given angle. So cosine theta is distance CQ in this picture. And I know sine is the y-coordinate. This distance is sine of theta, which is to say sine of theta is which distance? Which distance? That's distance PQ. Okay? And there's one more that is of interest. There's one more that is of interest. That is, what is tangent of theta? Well, it's not in the picture yet. I'm going to draw it in here. But before I do, I want to just take a quick little, you don't need to be able to reproduce any of this. This is more of a be familiar with the picture. So if you see it again, you're familiar with the picture. It's not going to be, a big deal. You don't need to reproduce this, but you should be familiar with this. You should have this information noted so that, I might throw a question or two at you about just to make sure you've looked through this and kept track of it. But in this picture, now let's just suppose, how do we know for sure? Well, we know sine is the y-coordinate because sine is y over r, and the radius is 1 because it's the unit circle. So sine of this angle is the y-coordinate over 1, which is just the y-coordinate. So sine of theta is the y-coordinate, right? Cosine of theta is the x-coordinate. But tangent of theta is neither x nor y. It's a combination of them. It's the y value divided by the x value. And the question is, where is it located in the picture? And it turns out, as it's currently drawn, it's not in the picture. I am now going to draw the line segment that determines the value for tangent. And the value for tangent is the tangent line. If you, from point R, if you erect a perpendicular tangent to the circle here, that's where the name of the function came from in the first place. That's where the name of the function came from in the first place. It's this tangent value. This distance is tangent of theta. Now, how do I know that? I know that because what I claim is, what is that? Oh, I need to label my little point there, don't I? P, Q, R, let's call this point T. And so in this picture, what I claim is tangent theta is TR, right? This distance. Now, I'm sure you would accept my word for it. You would accept anything I say. You sort of see me as, ooh. But let's just make sure that we know why that's the case. Pretend we don't know. Let's call this distance N. Now, what do we know about tangent of theta? I know tangent of theta in triangle CRT. In triangle CRT, see my big outside triangle? Tangent of theta is opposite over adjacent. But CR, adjacent, we know what that distance is. It's the unit circle. That distance is 1. And so that simplifies to say tangent of theta is that distance N that we were looking for. Well, what is N? N is TR. And so from that argument, it shows that this distance is, in point of fact, tangent of theta. Now, you don't have to be able to prove that. You don't have to make some sort of an argument. All you need to do is be familiar with this, so that if I draw this picture, and this multiple choice question just writes itself. I just draw the picture on the exam and say, which distance is tangent of theta? And I give you a couple choices. You pick the right one. Or CQ corresponds to which of these functions? I give you CQ, and you pick out the correct function. So this doesn't happen a lot, but when it comes into play, it's a really, really important picture. So I want to make a special little video to talk about that. So you have that sort of off to the side, ready to go, just in case you have some instructor that's kind of a doofus and throws this on the exam someday.